Are you ready for more difficult area between curves problem? So these three problems, they are all vertical rectangles. You have to use dx integral. What makes these three problems so interesting? So let's take a look at the first one. Don't worry about reading the function. Do you see that I have two curves, one white, one purple? So we have two regions. So we have region A and then region B. In region A, the white is above the purple. However, in region B, we have the purple above the white. So we have to set up two integrals, one for A, one for B. So what goes for A? First of all, since the top and bottom changes at this intersection, we will have to figure out the intersection. And then regarding the inequality between 0 and 6, so since we cut at x equals to 6, so that's why we have a region B after you found the intersection that should be equals to 4. I know the answer is equals to 4 because I solved the problems already. So let me show you how I get the 4. So you have to do some algebra, and let's say this is an exam problem, you are expected to do this part by yourself. So first of all, you have to let the two functions equal. So the cube root of 2x is equals to 1 over 8 x squared. And then you raise both sides to the third power to get rid of the cube root. So you raise both sides to the third power. So now on the left hand side, the cube root is gone. Then you have 2x equals to 1 over 8 times 8 times 8. And then 2 times 3 is equals to 6. And then you multiply 512 on both sides. And then let's do the works right here. And then you have 1224x equals to x to the 6. And then you move the 1224x to the other side. You have x to the 6 minus 1024. Did I say 1224? X. And then you do a factor. You factor out 1x, so that is a x, and then x to the 5th minus 1024. So using zero product property, you have x equals to 0, and then x to the 5th minus 1024 equals to 0, x to the 5th equals to positive 1024, and then you raise both sides to the 1/5 power. Because that is how you get an x on one side, 1024 raised to the 1/5, that is equals to 4. That is equals to 4. So that's why we have from 0 to 4. Let's leave those space for problem 2, because for problem 2, I want to go back up so you can see the picture. Now, for region A, which one is on top, which one is on the bottom? I don't even need a rectangle. By the way, I can just do this. A point, and then another point. You don't even need the rectangle. If you want to, just draw it. You can go like that, and then draw a rectangle. So this is your rectangle, and then the top of the rectangle is touching the cube root function. The bottom of the rectangle is touching the square, right? So you can say that this is from x equals to 0 to x equals to 4. And then the top is y equals the cube root of 2x. And then the bottom is y equals to 1 over 8 x squared. And then now region A is equals to x equals to 0 to x equals to 4. If you are doing homework online, I don't think they want you to write the x equal. Just write 0 to 4. And then you use the top minus the bottom and then dx. So the first step is done. This is for region A. Alright, but the problem is not done because we still have a region B. So for region B, let's switch to another color. For region B, what do we have? We have from 4 to 6, right? So we have from x equals to 4 to x equals to 6, and then the top and bottom, they change, right? Right here, the yellow. Look at the yellow. Look at the graph. Region B. So the purple is on top, the white is on the bottom. So the top, that is now y equals to 1 over 8x squared. Let's go back to check that one more time. Look at the purple curve. Look at the graph on the left. Do you see that on the yellow line, the top is touching the purple curve, 1 over 8x squared. The bottom is touching the cube root. So the bottom is y equals to the cube root of 2x, which is just the opposite of this, right? So for region B, you have from 4 to 6, x equals to 4 to x equals to 6, and then you have the top minus the bottom, and then dx. So what is the final answer? The final answer is this integral plus this integral. And then that is only for the process where you set up but do not evaluate. When you do homework online, I am pretty sure that you will have to go all the way to the end, but I am not going to do the integral evaluations right here because I want to save more time to do the area, because the purpose of this lesson is discussing the area, right? Not evaluating integral. All right, so that is for number 1. So again, the answer is this integral plus this integral. And then you evaluate what that equals to, add them. Okay, so that is A. And then for B, let's switch to another. For number 2, let's switch to another color. And then I will draw a line to define the work. So for number 2, what do we have? Number 2. Okay, for number 2, it looks like we have region A and region B. All right, so region A is the green above the orange. B is the green above the orange. But what is different? Look, you have an absolute value function. First of all, if you put a minus in front of the absolute value is just looks like a V shape, right? If you put a negative in front of the absolute value, you put the V upside down. If you add 2 to it, you will just shift this vertex 2 units up. So that's how you got the green curve. And then on the left hand side of the y-axis, you have 2 plus x. Just look at that line. Don't let the absolute value confuse you. Do you see that the slope is positive? So that must be 2 plus x, because the line is going uphill. The slope is positive. And then on the right hand side of the y-axis, the line is going down. The slope is negative. Then you have 2 minus x. Again, when you do this type of problems on homework, quizzes, and exam, it is your responsibility to draw the graph and then do the labeling. All right, so let's get rid of the V. First of all, let's find the intersection, because there is an intersection right here and then right here. So how do we do it? So the first one, we set the x to the 4th equals to 2 plus x. And then we solve it, x to the 4th plus x minus 2 equals to 0. So this one is x equals to 1. And then on the other side, you have x to the 4th equals to 2 minus x, and then x to the 4th, here, no. Minus x minus 2, and then you have x to the 4 plus x minus 2 equals to 0, and then you factor that, you have x equals to 1. X equals to 1. So this is a negative 1. And then this is a 1. And then of course the middle is 0. One minus, wait, di, let's see. 1 and, okay, 1 and negative 1, because this is 1 plus 1 minus 2 equals to 0. This is this should be a negative 1. Okay, here. This is supposed to be negative 1. So you have 1 plus 1 minus 2 equals to 0. Okay. All right, what else? Now you have to handle 2 integrals, one for region A, one for region B. So for region A, we have x goes from x equals to negative 1 to x equals to 0. And then the top is the green, right? 2 plus x. The bottom is the orange, x to the 4th. Then region A is equals to integral from -1 to 0, and then you have 2 plus x minus x to the fourth dx. But in this case, the the parenthesis is not necessary. So that is for A. And then for B, let's draw a line to divide up the space. And then for B, that will be the other way around, right? Oh, sorry, not the other way around. For B, so let's choose another color for B. So for B, we have from x equals to 0 to x equals to 1. And then you have the top, that is 2 minus x. The bottom is x to the fourth. Then you have from 0 to 1. And then you have 2 minus x to the fourth dx. So what is the final answer? The final answer is this integral plus this integral. So evaluate that. If you just do the setup but do not evaluate, then that will be the sum of these two integrals. So when you do homework online, you have to go all the way to the end. Then you have to use simple power rule, integrate, and then use the fundamental theorem of calculus, plug in 0, plug in -1, do a subtraction to get the value. All right, so that is the end of number 2. So moving on to number 3. So number 3, I put the problem right here for you. So let's move the problem up a little bit. So for number 3, I make the graph nice and big. So where is the region? So first of all, we have 1 over x, which is the blue function, the reciprocal function, and then y equals to x, a straight line, y equals to 1 over 4x, a straight line, but the slope is less steeper. And then we have the region right here. We have the region right here. Okay, but here, look, this region, I would like to define the region right here. Why do I have to do that? Because if you look to the left-hand side of the yellow line, do you see that we have the, what color is that? The y equals to x over the 1 over 4x. If you look at the right-hand side of the yellow line, we have the 1 over x over the 1 over 4. So that means on the left-hand side, the top and bottom, the right-hand side, this is the top and bottom. And then you also need to find out the intersection. So how many intersections do we have? We have 1, and then we have 2, and then we have 3. So for the first intersection, this must be 0, and then the one that is touching the yellow line, we don't know, but that one we can find it. So we have to let 1 over x equals to x, multiply x on both sides. And then we know that x is equals to 1 and -1. So x is equals to 1 and -1. Oh, where is the -1? The -1, do you see that the 1 over x, that is a reciprocal function? So there is another piece in quadrant 3, right? But we do not concern about that piece because we want x greater than 0. So that's why this x equals to -1. We can disregard this. We got that. And then what about the other one? The other one is the intersection of the red and the blue. Then we have 1 over x equals to 1 over 4x. So 1 over 4x, that is like 1 over x equals to, actually we don't need to go that step. So first thing, you have to multiply you have to multiply x on both sides. So that means we have 1 over x times x, that is equals to 1 over 4x times x, so that is 1 over 4x squared, and then you multiply both sides by 4, so you have x squared, and then what do you have? You have x equals to plus positive 2 and negative 2. Where is the negative 2? The negative 2 is the red line goes to quadrant 3 as well. For the reciprocal function 1 over x, there is another piece in quadrant 3, so that's why there is another intersection. Since we want x greater than 0, then we don't need the negative 2. Then we have 0, x equals to 1, and x equals to 2. All right, so let's divide this into two regions. So first of all, let's work on region A. So for region A, we have x goes from 0 to x equals to 1, and then the top is the straight line, And then the bottom is the also straight line, but 1 over 4x. So we have from 0 to 1, and then we take the top minus the bottom, and then dx. So that is for region A. And then for region B, that goes from 1 to 2, all right? And then the top is the reciprocal function, the bottom is the straight line, 1 over 4x. So you have from 1 to 2, 1 over x minus 1 over 4x dx. If you do set up but do not evaluate, which is what I ask my students to do on written exam, then I want to see this integral plus this integral. You have to add them because they are two regions. You add them. So this is the setup, but do not evaluate. When you do your homework online, you have to go all the way to the end. You have to use simple power rule, integrate, and then you have to find out what that equals to because they are looking for an area. All right, so that is the end of this lesson. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel if you haven't done so. I will see you all in the next lesson. Signing off for now.